Hello and welcome to today's light metal framing webinar. My name is Craig Johnson. I'm the Business Development Manager for Steel with Trimble in the UK. The light metal framing webinar, it's going to be in two parts, and today we're looking at the modelling tools and the drone production with Tekla Structures for light metal framing. A couple of housekeeping things here. So if you want to ask us any questions during the webinar, then please do so, and you can do that by filling in the questions tab there in the GoToWebinar toolbar. We will look to answer the questions at the end of the webinar, and if we don't have time to get through them all, then we follow up by email. Recommend viewing the webinar in full screen mode, and that means you're going to get the optimal webinar experience as a viewer. The webinar is going to be delivered by the UK Steel team, so that's myself, Craig Johnson, Business Development Manager, and then we have Chris Gatehouse and Radu Trankau, Account Managers for the Steel team. So Chris Gatehouse is going to take us through part one, and then Radu will take us through part two next week. Tekla Structures licensing, it's now subscription licensing, and we have three license types there. The one we're going to be looking at today, it's the diamond license, and that's a detailing and fabrication license. So what do you get with that? It's a multi-material license, so you can detail light metal framing, you can detail hot rolled steel, you can also detail concrete with reinforcement and things such as timber and also glass. So any kind of hybrid structure. The licenses are online, so it's quite easy to work from the home or the office. You just sign into the software rather than having an entitlement on a server. And each license comes with a copy of Trimble Connect. And also licenses are subscription, so it's really flexible to suit your business needs, whether you need to increase that license count at any point. And yeah, just to recap on what's included. So as I mentioned before, you get Trimble Connect with that. So this is the collaboration license that would be included with the Tekla Structure subscription. So that's it's available on the web. It's also available through Windows. It's on mobile, so it's Apple and Android, and it also sits on the HoloLens application. So that's the mixed reality headset. So there's quite a good different kind of use cases for that Trimble Connect license. You also get all of your UK profiles with the license. So these are all in as a default, and they include the cold rolled as well. So you would get a full UK section catalogue of hot rolled. All of your different steel grades are in there. And you get all of your different UK cold rolled suppliers. And any sections that aren't in there, you have the ability to create your own profiles based on the geometry of the profile that you need. We also have a lot of cold rolled partners, so 13 in total. So this is a snapshot of all the different partners that we work with. And as you can see, it's got kind of the main cold rolled suppliers in the UK are all on the system. Not only are their profiles on the system, all of their components are on there as well. So ancillary items, connections, all based to their standards. And you also have the ability to use file transfer tools, which link directly with their machinery. So you can send cold rolled drawings and files off to them for manufacture directly from the Tekla model. You also have the ability, as I mentioned before, to create your own components. Tekla is very customizable, so you can create all of your own parametric components and specify them in the framing tools. And this is kind of an overview of the framing tools that are there. So we have the metal framing panel tool, you have the panel connection tools, opening tools. If you're using a specific manufacturer such as Howick, then you have all of their connections available in there to specify as well. And you can also use your own. We also have some metal framing links available on Tekla Warehouse, which is part of the subscription package. So this is just a few that are on the system there. We also have a UK and global development team who work on keeping these things up to date and also making any improvements to the framing tools based on customer feedback. And we also have various other machine exports. So we have the NC and DSTV for the hot rolled exports, IFC for the collaboration. We have DXFs, you have CSV and XL. We have XML exports and also step exports. So you can pretty much link with any kind of manufacturing machinery directly from the Tekla model. And what type of projects is Tekla typically used for? So residential structures. So this is a view of the model. And then we also have a photo rendering suite within Tekla called Visualizer. We see small load bearing projects with cold rolled framing and hot rolled steel. So you could get all of the manufacturing information out of that one model. We also see a lot of infill projects being used for Tekla. So that could either be a concrete based model or a steel based model, and then you would take that model and then put that infill in there. And we see a lot of large load bearing projects used in Tekla as well. So that could be really large projects with multi-materials, so hot rolled concrete, really complex kind of structures, and Tekla can handle them no problem. And then we also see a lot of volumetric modular construction as well. With being able to do the hot rolled and the cold rolled in one model, then it's a really good tool for these kind of projects as well. So just kind of a bit of a run through of what we're going to cover today. So we're going to just look at 3 examples. So that's load bearing, infill and volumetric. We're going to give an overview of the framing tools and how they work. And we're going to create a few drawings, GA's assembly drawings, and then manage some changes within them. So it's going to be Chris Gatehouse who takes you through the demonstration now. I will hand over to him and I will be back at the end to answer any questions that come in. Okay, thank you very much, and over to Chris.
Hi, my name is Chris Gatehouse. I'm an account manager here at Trimble, and I'm going to be running you through a demonstration of some of the light metal framing functionality that is available inside the Tekla Structures environment. I have 3 examples for you today. I've got a residential building, I've got a concrete structure, and I've got a volumetric unit. But I'm going to start with the residential building, and I'm going to show you how we can populate this with some light metal framing panels and cassettes. So my starting point is a 1:1 scale PDF drawing from the architect. I imported this earlier, scaled it up, and I positioned it inside environment. And I'm going to populate it with some light metal framing now. So my starting point is to go to my applications components library and bring up my framing panel. And I'm just going to talk you through some of the settings inside here before we get cracking. So just draw your attention to some of the key ones. So we have the height specifications for both ends here and here. This allows us to do asymmetric panels. We've got specifications here. It's named horizontal brace, but it's commonly known as noggins. So the height for that is 1400 here. And then we're having I'm splitting all of them, and I'm going to offset them 50 mil from each other so that they're staggered. I'm specifying down here that my studs are 600 centers, and I'm specifying that my maximum panel length is 3.6 meters. Just to complete this, on the bottom right, we've got specifications for diagonal braces, and you'll see how those are populated in a minute. But basically, we're saying position brace A in bay 1 and brace B in bay 6. The second page for parts is where you configure the parts within inside the component. The main thing to note here is the specification for the section size. So the CC prefix is a parametric prefix for lit C sections. And this means that you can configure the section size to suit whatever your machine can manufacture. So in this example, we're using a 100 deep section that is 1.6 mil gauge. It has a 15 mil lit return and a 41.3 flange. If we hit the select button though, and you're using manufacturer sections, you can go into the library and you can find those manufacturer specifications and specify them as necessary. So you've got flexibility to use known sections or more parametric sections if you need to. Okay, so let's go ahead and populate the model. So we start the framing panel tool, and we don't have to populate one panel at a time. We can specify a number of panels by just tracing over the wall, like so. I'm just going to do one more return to this corner here, and then we hit middle button to complete, and that populates the model. So you can see we've got framing panel, we've got a bottom track, head track, we've got our studs, our noggins, and our braces, all as specified, and you can see that they are being broken and joined at 3.6 meters. Wonderful. Before we go any further, I want to just explain about the connections as well. So inside the applications and components catalog, you will find a raft of connection types across most industries, but specifically for light metal framing, we can have a look at these Howick tools, for example. So you can see we've got a Howick connection. You can customize and create your own connections in here and have those referenced inside the panel component. One of the ways that works is by saving standard files. So in this example, we can create a number of variations based on the connection situation. So, you know, the head, the bottom track, the noggin, they might be slightly different connections. So we can use the attributes within this connection component to build in those variations and then save them as those variations. We can give them names. So you can see we've got a few examples here. Once we've got those standard files, what we can do is we can reference those inside the panel component. So if I open that component, go to connections, you can see we've got a number of available fields that reference specific joints. So the top line is where you specify the connection type, and the bottom is where you reference the standard file. So inside here, we can go to the Howick tool. We can pick the connection that we've saved the standard files for, and then we can pick the appropriate connection. So we'll pick track for the top. We can pick this one here for the bracing. So again, go to the Howick tool, pick the Howick connection, pick brace, and then we can carry on like that as well throughout here. Let's go to Howick tool. Let's do one more. And that one we can call H brace ends. There we go. And then we store that. We can apply it to the components, and they get included. Let's take a look then at how we might be able to populate this model with some openings. So what we're going to do is, if we select the panel and we go to the contextual toolbar, you can see we've got a number of tools. And one of them is adding opening with 2 points. And since we've got the window position here, we can use that option to populate the window. So let's pick that and then just pick the extremes of either side of the window. And you'll see that it now adds an opening. So you'll notice that we've got kind of cripple studs, and it's doubled up the jamb, doubled up the head and the sill as well. Now that we've got this in here, we have control over the opening, so we can modify it. So if I bring up the properties for the opening, we can make it wider. So we can make it 1500, make it taller. We can lower the sill, so we can go down to 700. We can also change the specifications for your lintel type, the sill type, and the jamb, so we can make it double, standard, or medium, heavy duty, whatever we need to do. But we can also include cripple studs over here as well. So if I put 300, 600, 300, 600 here and hit modify, you can see we then get sort of mid-ish position additional cripple studs as well, if you need to really bolster those up. Okay. This also has direct modification functionality as well, so we can actually drag and drop the position of the window. So if I now grab that edge, you can see I can make it bigger or smaller based on where I then reposition the head and the sill, that sort of thing. So quite a lot of flexibility in how we set the geometry for this. We can also use the same tool to put the door in. So if we select this panel, use the same opening tool with 2 points, we can pick the extremes of the door and populate. Well, it starts with the window because that was the last specification that we used. But if we go into properties, and I've got a preloaded door, but really all that is specifying the height of the door, setting the sill level at 0, and at the bottom track spec, we say it's split. And if we modify that, you'll see the jambs change to singles because I haven't set them as doubles here, but you'll also notice it breaks the bottom track to allow a door to be modelled in. We can use the same tool for floor cassettes. So if I open the framing panel, and again, if I load a preset cassette in here, I'll explain the differences. So I've specified a 150 deep section for the purposes of this. I've also changed my back-to-back specification, so I've specified all studs to be back-to-back, and I've also set the panel rotation to 90 degrees, which is going to lay it in a horizontal plane. So once that's applied, I can then pick the edge of my panel, like so, hit the middle button, and it now populates the model with 3.6 meter long floor cassettes. Okay, so jumping a few stages ahead, we've completed the ground floor level light metal framing. We've got the walls, openings, we've got cassettes. You'll also notice there's a hot roll frame in here as well, forming the core. And I'm going to show you how we can very quickly populate the rest of the building. So I've predefined a filter which allows me to select only those hot roll panels. We can right click, copy special linear, and then we're specifying 2800 in the Z direction because we know that's the panel height. We hit copy, that creates an entire floor of metalwork without any of the time taking the detailing. So one of the things that you'll notice is that all the openings are copied, which is not normally a problem except for the door openings. On the first floor, obviously, unless you've got a balcony, you're not going to have a door opening, but this is quite straightforward. So using the tools that we saw before, the window opening, I can now pick that opening and I can bring up the properties for it. I can re-specify that as a window and then hit modify, and now that door becomes a window opening. So very quick way to redefine those windows. So once we've got the first floor modelled up, we'll probably want to turn our attention to the roof. And we can do this very simply. Again, copying these panels that we've got on the first floor, copy that up. Once we've got that, we can take advantage of the direct modification tools, which allow us to manipulate the shape of these panels just by dragging and dropping. So we've got these controls on the ends and on the top, actually on all the edges of the panel. And to manipulate the shape of the panel, all we've got to do is drag and drop it, like so. So if I move that down 600, you'll see the panel will reduce 600. And if I undo that, that will go back up again. So let's move that back up 600. What we can also do with these controls is you see we've got this midpoint handle. If I grab that and drag that up, I can introduce an occasion into the panel. So it's a very straightforward way of configuring your panels to suit whatever profile you've got, or indeed whatever panel you need to model. We can do the same thing at the other end as well. So we can grab that panel, drag that up 900 to the apex, like so. Okay, I'm going to copy up some of these walls and elevation as well. So let's copy those up to 100. I'll show you a little something we've got here. So got those in, and we can use this configuration. We can use this functionality here to model in a roof truss. Okay, so if we go back to the framing tool here, I can load a predefined truss here, and if I draw that across from there, I snap perpendicularly to the edge over here. Just trying to get roughly the right place. There, and we button that. You can see we've got what you probably recognise as a floor joist. And if we grab that and raise that up, you can see we can detail a roof truss. Now, it's very straightforward. I know it looks quite radically different to this panel, but if I just show you simply what we've done here, the only difference is we've taken out the horizontal bracing, so the noggings, and we've simply gone down into the diagonal braces and told Tekla how to distribute brace A and B to achieve the diagonal lacing layout that we want in here. So it's pretty straightforward to detail any kind of truss really. You know, if you've got a lintel truss or floor joist, you can use this to configure those as well. So in the second example, we're going to have a look at a concrete infill project. So you can see we've got a very basic concrete frame here. We're going to see how we can leverage the metal framing tools to allow us to populate this. So if I just go ahead and very simply put in a framing panel from point to point and click the middle button to complete, you can see we've got a frame in there. A couple of issues with here. You can see one, it's penetrating the slab. So using that direct modification that I talked about earlier, I can grab that top track and bring that down. We've also got two panels at 3600, which has resulted in a 200 infill because this bay is 7.4 meters. So we can either go into here and consolidate that down and say, okay, we'll give me two at 3700, which will give the infill, or with a panel like this, where the frame is providing all of the stability, you probably don't want the bracing. And particularly if it's like an SFS infill project where you're just providing you're providing straight lengths, either cut to length or cut to site, but you still want to calculate it. You can specify a 7400 panel just so you make your best use of the material. So once we've configured it, we can continue to go around the frame and model those in. I've just spotted something else as well. That's obviously oversailing the column. Now, if it was a facade or something, you could do that. You could bring it forward, pass it across the concrete. But because this is infill, we actually want to bring that back to the face of the concrete. Or we can use some of the inherent tools and we can copy linear that from that point to that point. Tekla will measure it for me. And then I want two more copies so I can copy that. Alternatively, what I can do, and this makes short work of this sort of work, is I can just say I want my panels to span along there. So that's not great because you can see what's happening is we're getting every 7400 we're getting a new panel. But what I can do inside the dialog box is I can say, well, I want a 7400 panel and then a 600 panel, and then another 7400 panel, and then another 600, and I can do that for as many panels I need, which is 4. And then you can see I've now got a 7400, a 600, a 7400, a 600. And what I can do once I've done that is I can tell it to miss panels 2, 4, 6, and 8. And it won't create panels to the corresponding positions 2, 4, 6, and if I had one, 8. Okay, so that's a really quick way of infilling an entire elevation whilst missing holes. Okay. Once you've got your panels in, you're going to want to start thinking about your openings. So what we can do is we can go into the opening toolbar here, and I'm just going to use add a rectangular, which is kind of a freehand tool. Just going to put that opening in there. Now, the beauty of these kinds of structures is that the window patterns are often repeated across the units, but instead of having to copy that manually, I can take advantage of our batch editor tool. So if I start batch editor, select the source panel, and then populate that as our source assembly, Tekla will identify for you all matching or corresponding panels. And then we just got to hit copy, and it will distribute that change to that panel across all our panels. So then we've got matching windows across the board. The final example I wanted to illustrate in today's webinar was for a volumetric modular unit. You can see I've got a pre-modeled volumetric unit with its end frame assemblies and the roof and floor cassettes. And we can use this framing panel to apply infills to this very, very quickly. So if I start the framing tool and set my rotation point like this, just to get a better view on it, I can zoom into here and I can snap to the tie member here for an example, click complete, and I can do the same thing across this bearer here, like so, and then I can edit this very, very quickly. So let's spin that around. Let's grab this, and I can grab that top bar, and I can snap that to the underside of the tie, It's not quite there, I don't think. Yes, it is. I can do the same thing with this one. So grab that, snap it to the underside of there. We had a gap here. Again, just grab that and snap it to that edge. Same thing this end. Grab that, snap it there. There we go. And we've still got the infill setting there, you see. So let's change that. Let's put that in as 2500. And let's not skip any panels. Like so. So we've got the infills. And again, you know, I can put doors in here. So if I select that panel and create some default views, and I can go to the end view, and I can add a door in here. So let's say there's a door there to there, 900. There we go. Got a door, and we can put a couple of windows in that elevation as well. So let's pick that again, create default views. Got our side view, and we can do a couple of freeform windows here. So let's go into here, and you'll see that it will split across panels. And let's get a second. Yeah. There we go. You can see very quickly I've got a volumetric unit, and I've panelled it out with light metal frame. Thank you very much. So now that the model is pretty much done, let's take a look at how we can break this model down into a series of drawings to allow us to make it. So first drawing type that we would normally look at is the general arrangement drawing, and that's what I'm going to create for you now. So I'm going to use this tool here, create GA drawings. I'm going to select a view which is going to form the basis of the views on my page. I'm going to load a standard steel plan, and I'm going to open that drawing when it's finished creating. Now Tekla is creating that GA for me. It's placing the view, it's setting the scale based on the settings that are specified for that drawing. And there you go, we can see we've got all areas of the structure, including the volumetric unit and the concrete unit. I'm going to remove those dimensions, those are auto dimensions, and I'm going to refine the area of my view on the page just to make it a bit cleaner. Okay. The other thing I'm going to do here is that's fairly meaningless to anybody. There's no grid, there's no references, there's no nothing. So what I can do is I can go into here and I can turn on the 3D layout, or the PDF, sorry, that we had previously. So you can see the two are overlaid. Now you can't. It's not very easy to discern which is which. So what we can do with the reference object is we can change its line type and its intensity to recess it and bring the steel forwards. Okay, so now you can see the two overlaid, and it's easier for an observer to review. The other thing that we can do with this is create some detail views. Okay, so the first kind of view that I'm going to create is a section view across grid B. So I'm going to pick a point on that grid line, and then I'm going to pick a second point over here. Then I'm going to define a depth for the view, like so, and then a position for the section. There we go. So that's a bit shallow, but I can grab that view, reposition it, and grab that top toggle. And I can just drag that up to increase the depth of view. Give that a second to populate. Not quite there. Let's give it a bit more. And then we'll get the roofing. Looks like that's enough. Okay, perfect. So there's your section view. We can change the scale on this quite easily. Just bring up the dialog, change the scale, hit modify, and that will scale it up a little bit. Once we've got this, we can add a bit more detail to it as well. So you can see we've got some hot rolled steel in sort of integrated into the frame. We can do a detail on that splice as well. So if I use my detail view, pick the center, pick the area, pick the position for the label, and then the position for the view. And again, that's a bit small. So bring up the dialog, change the scale, 1 in 10, hit modify, bring that up. Okay, and then we can use all of this for standard tools inside here to add a little information. So we can add some dimensions, we can add part master plates so that the erector knows what he's looking for. And so if I say it's in position, we've got SP2, reposition that, make it all good. So once we've got the GAs, we can think about the assembly drawings. And for this, we can use our drawing wizard. And what I'll do is I'll start this up, and I'm going to select just a couple of example panels just for the purposes of this. And I'm going to use my steel fabrication drawings, excluding single part views filter for this. Now, it's important for me to point out that I have customized this and the layout of the drawings. This is an out of the box, but it is very straightforward to do. So that's finished. Let's have a quick look at the drawings. So you can see we've got those three frame elements here. So if I hit that button there, we can isolate just those ones by selection in the model. We can open those to review them. So you get your bit of materials, you get a general notes box and your states box. And you can see we are looking at a view with some part marks, some reference lines, which for the purposes of this are actually either down the center line of the bracing members or the web face of the track and stud members. We can tidy this up a bit. Let's take these part marks off here. Let's put them on this main view. Just like so. And if we need to, we can add some dimensions, generally speaking, because these holes are generally dimples. Dimensions generally probably unnecessary. We can give it some overall dimensions though, just to give you an idea of the overall size in terms of checking dimensions, that sort of thing. These are often helpful, so we can pop those on. It's not very difficult to do that. Or if you want to spend some time tailoring your layout, you can create those specifications so that you are creating the layouts out of the box. Let's take another look at a more straightforward panel. There we go. That's a general panel, and then a floor cassette. Again, you can add the dimensions to suit yourself. We can also take a look at the hot rolled fabrication drawings as well. So if I bring the drawing document manager back up again, we can have a look at some of these hot roll members. So there you can see we've got a beam with the splice details. Very little editing is required on that, if any at all. It's worth noting that these are out of the box, apart from the broken line, which is just a background setting, which is easily changed. So the editing rules, they are out of the box. And you can see that they're pretty good. There's no editing required there. Having a look at this column, it's got some stub details. You might want to embellish that slightly, but in the similar way that we put the information onto the general arrangement drawing, we can do the same with the fabrication drawing. So we can add a section view, place that onto the page. Now, we can manually adapt that, or if you just say arrange drawing views, Tekla will fit it to the next sort of appropriate drawing page size. And if that top is the same as the mid section, which it is, all I've got to do is put an section mark annotation instead of creating another section. Now that's come in as A. If I double click on it, I can modify it. And I can just hit that like that. And then we can just add a few dimensions onto here, just to give the fabricators an idea of what they need to do. Like so. Very quickly then, we're going to have a look at how we might be able to manage changes in the model. So we've got the drawings that we've created already, and we're going to create a change, and we're going to see how we can keep track of that. So the tool that we're going to use is this checkpoint tool here. So I'm just going to hit that button to create the to start creating that checkpoint. You can see the document manager has blanked. And then what we're going to do is we're going to back to the model, and we're going to leave that open, and we're going to make a change. So all I'm going to do is I'm going to open this window up a bit. I'm going to widen it. And Tekla's going to catch up with that. The component's been rejigged, and you can see that we now have a drawing that's listed as changed. So once that's happened, what we can do is we can keep track of that. So if we uncheck that, we get a warning that says turning off show change will reset the changes checkpoint and the history, but it's prompting us to create a new category. So we can hit that, and we can say, for argument's sake, that it's change order number 1. We can hit save, and now that has created a filter on the left here, change order number 1. So although we can see all of the drawings, we can hit change order 1, and that's going to list all of the documents that were affected by the change that we did in the model when we started that checkpoint. So then we can revisit that, and we can see what the effect of that change has been. And in this case, it's been to have increased the width of that window. So a really good tool for helping you to keep track of the changes inside of your model and the relationship with the drawing.